Do we have a note taker?
Well, yes.
We need a note taker. Please, please. All right. Thank you. It's Lisa. Back there.
Okay, once get started.
We're ready to get started.
Right. Okay. Welcome to Bangkok. Welcome to ICNRG. It's great to see you. So this is the research group on Information-Centric Networking in the IETF. My co-chair is Dave Oran, and I'm Dirk Kutscher. It's great to see you. And just quickly, let's run through some housekeeping things. So we are following the IETF IPR rules here. So in short, this means you are expected to notify us if you contribute something of IPR relevance or if you see something being contributed. We are being recorded. Make sure you use the on-site Meet Echo tool and scan the QR code. And yeah, we'd also like to remind people that, so this is the Internet Research Task Force. We are not doing standards at all. So we want to work on, say, long-term research issues that could, inform the IETF, could lead to interesting experiments and results. So there are no standards here. If you see RSC published, it's typically informational or experimental RSCs. So we work really differently compared to IETF working groups. And so, yeah, we have a mail list. Please subscribe. We have a wiki page, and we have a note taker. I think Edison, right? Yeah, thanks. Yes, thank you very much. Please use the note-taking tool. Then it's easier for other people to chip in missing pieces, and it's also easier for us to generate the minutes in the end. Okay, so we have 90 minutes today, and you can see a pretty full agenda, so we have to keep an eye on the time, but I think we can manage. So we start with a really interesting research presentation by Prisham Mekbungwan. And then we have a couple of updates from Mark on Flick, on content object chunking and versioning, a new idea on versioning. And then we have an update on the reflexive forwarding draft by Hitoshi. Dave is doing good. Yes, right. Sorry. And then we have Aijun Wang giving us an update on the distributed microservice activities that have been going on in the IETF. So he will talk more about this, and you will learn. Okay. Any questions on the agenda? Right. Okay. In that case, let's get started.
Get going.
Prisha, you can come.
We can share your slides and then give you a clicker. How's that? Here,
right. So we need to pass control to the clicker.
Right.
I have it here. I have it. Yeah, it works. Okay, you should slides.
Hello. Thank you for the opportunity for us to present this work in the IETF. So this is my first time in the IETF also. So, so here is this is our talk on the research work of the offline content access with the NDN and the 2D communication. So the team has me, Prishai Mekbangwan, Adison Lertin Saptavi, Kanchana Sood from the Asian Institute of Technology. And we have Marcelo Diaz, Tim Omorim, and Sophida from Sorbonne University. So let's get started from the problem that we are working on is which is the unaffordable internet access, where the internet access can be expensive for low-income household, or either can be like for the people in the area that in the remote area that lack of internet coverage. So these people lack of the opportunity to access the online valuable content and to be that will be useful for them. And so from this stereo, it works. So we want to provide the offline content access using device-to-device communication. So in this scenario, we have allowed user to pre-download the content from the internet for the subsequent viewing later and for sharing with their community. So this content we store at their on their device, and then when they get to the community, this can be accessed by the device in the vicinity area using the 2D communication. And we have implemented the prototype according to this use case. So we use the implement the simple file transfer application on the Android device, and we use the Google Nearby Connection API for the D2D communication, which working based on the Bluetooth and Wi-Fi Direct. So here in our demonstration, we have two types of two users device and one station. And so the station is where it's a central device that we can use for synchronize the directory information. So in the first step, here the user device, Alice and Bob, will send their own directory information to the station, and then the station will compile the list and then send to all every device in the vicinity. And then here the directory information is showing to the user. So user can select which file is which content they want. Then the application will get the contents based on the device that has the content and connect it to get the file transfer working, and then to complete the download. So with this prototype, we perform the experiments on the measuring the transfer throughput between two devices with different distance between them. So we can achieve the distance up to 130 meters and the throughput up to 15 megabytes per second. In the end, DTD is good, but we want to improve with named data networking and the NDN, which allow us to decouple the content from its physical location. So this device can forward the request based on the content availability, not based on the location. So this enables the multi-hop content discovery and retrieval. So in our case, we can use the NDN as the content management, where the name-based forwarding can be used as the content discovery service, which allow the content to be located by name regardless of where it is located. And we also utilize the in-network caching mechanism, which allow the content to be cached by the device when it is forwarding. So this can improve the performance of the system when the cached content is closer to the requesting device. However, there are some challenge when implementing the NDN on the D2D communication. The first thing is because the native of the D2D is the opportunistic connectivity, and this will need to be handled outside the NDN. So in this case, we utilize the long lifetime interest packet to allow them to maintain the validity between across the when the connection are not available until the new connection is established again. The second is with our use case, we want some of the pushing mechanism, but is not support natively by the NDN. So in this case, we introduce the persistent bit record, which the record will be kept even when a data is matching and is received, allowing us to like push the data to be forward by the system. And the D2D also have the discovery and communication setup procedure before it can be used for transferring data. So this will have to be handled. So we will introduce a D2D communication manager that interface between the NDN forwarder and D2D layer to manage the D2D connection procedure and passing the message between it. And there are no, currently there are no standard API for different D2D technology and platform. So in our case, in our use case, we focus on the Android device because it is more affordable for people. So, and so we use the Google Device Recognition API for the D2D connectivity. And the last one is because most D2D device often have the limits resource such as the storage. So we use this RU caching and we'll prioritize the storage for the user prefer content. So here is our NDN over D2D architecture. So we have normal NDN forwarder and the content repository for keeping the content. And we introduce the content manager and D2D communication manager. So the content manager manages the access and storage of the content in the repository as user requests. And whenever a user requests the content that is not available inside the repository, it can create an interest to request from the other devices. And it also push the directory information to the other device, so they can see which content is available nearby them. And the second component is the D2D communication manager. As I already mentioned, they manage the connection during the discovery and connection establishment. And they also manage the D2D phase in the NDN forwarder and its corresponding flip records. Also, interfacing passing message between the NDN forwarder and D2D connections, and they also send the pending interest to a newly discovered peers when it is detected. And yeah, as I already mentioned, we have two mechanisms, which are long life interest for the opportunistic connectivity, and then persistent peak record for data pushing. So with this architecture, we here this is how we implement the content discovery and retrieval in the NDN over D2D. So this we are motivated from the work from the Emmanuel Battery in 2014. So in this case, we have designed a new naming scheme. We have the first one is D2D as a prefix, followed by the part of the file and end with the chunk number. So at first, the first step that the consumer will send the interest for the first chunk of the file, and this will be sending forwarding to all channel is available until it reaches the data source, and data source will just return the data for the first chunk. So during forwarding the data back to the consumer, this can be the phase that incoming data will be recorded in the fifth phase. So we can have a temporary fifth record pointing out to the data source with the prefix. So we have a path from the consumer to the data source. So the subsequent chunk route directly from the data source and get the data back to consumer. Yeah, also here we have implemented the proof of concept from our design. So we have here is on the left side, we have the data source which has two contents here with two chunks, test/1 test and test/2. And firstly, the consumer will send the interface for the first chunk, and then the interface is sent to the wildcard interface for the D2D. So in this case, when it receives the data, so and then you can see that number 4 on the fifth record there is the new temporary fifth record created, pointing to the data source. So when the interface is the subsequent interface is sent, it will be sent to this channel directly to the data source and get the data. So from this, currently our research here is a key takeaway that we have. So our research that we can highlight that the increasing content access can elevate the importance of the ICN. So whenever the content is available within the network, the ICN can deliver the content. However, the delivery time maybe depends on the network topology or type of the connection. The second one is when here the pre-downloading is becoming increasingly important, as especially in our case, because it reduces the dependency on the network conditions. And for the successful delivery, D2D contact time is very important. So to ensure the complete file transfer, we suggest for the last file should be chunked into smaller parts and to be reassembled at the receiver to be before the viewing. And there are still further studies to be investigated for like a performance tuning aspect, such as the caching, chunk size, and different contact time. Here is our future plan. We plan to have a real-world experiment in a few months at the migrant worker camp in Samut Sakhon, Thailand. And then there is performance tuning, which has to be investigated. And then we want to have interoperability with the internet connection to allow the exchanging content with multiple remote D2D networks and cloud servers. So we can extend the application with the real-time audio, video streaming or chat message and allow us to have the virtual classroom for those people. And so before ending, I want to thank you for the THNIC Foundation for the research grant, and this allows us to kickstart our project. So thank you very much, and thank you for your attention.
Thank you. Thanks, Bichai. We have time for questions.
Hello, this is Thomas from Hamburg. Thanks for your presentation. Interesting work. Would like to make one remark on your push versus persistent pit state approach. I mean, the problem is old, and it's clear why you want to do this, but I would warn a bit, because it can get in all kinds of trouble by keeping the pit states, including routing loops, state management, and all forwarding loops, and all these kind of things. There have been quite a number of successful approaches to solve this otherwise. That's basically by getting note of that you want to request a content, and I would suggest that you just look at what the lower layer IEEE 802.14.5 defines as indirect transmissions that actually solve this problem, which is bound to a certain lower layer anyway, but I would suggest that you have a look there and then rethink this a bit. Yeah?
Yes, thank you very much.
Hi, Dan York. Very interesting work. Thank you for bringing this here. One question. When you said you had a long-lasting connection that you were doing, I'm just curious. How long was the
You mean the long lifetime interest?
long lifetime? Yeah.
Yes, it could depends on the scenario, but in our case, it could be like 1 minute to 20 minutes or something like that.
Interesting. I guess my other question.
It depends on the type of the content and how far the network, the topology is.
Yeah, I'm also just sort of curious. I've worked with some other offline solutions to do this kind of thing, but they've usually been a client-server model of something of, somebody brings a Raspberry Pi somewhere or something, and other people can offload off of that. I'm just curious, what put you on the path of doing this with a NDN type of approach?
We use the phones instead of the Raspberry Pi, because the phone is more like affordable for people, and like everyone already have the phone, right? So if we use the Raspberry Pi, then maybe we introduce more cost to them, and yeah.
Sure. Sorry, I guess I meant what was why did you pursue doing it through an ICN, CCN, NDN, whatever we want to call it, a content-centric approach? I was just curious.
Because if we can write ourselves the outer layer of the content recovery, right? But it's already on the NDN, and then we want it to incorporate with, work with the internet and on the server, that if we can have use some standard or some baseline framework we can use, then I think NDN ICN is one of the potential.
Okay, cool. Thank you. Thanks for bringing this here.
You're next in the queue.
I joined you on the queue.
For the NDN, for D2D communication scenario, normally is host to host. So I want to ask, is there any scenario that there are many devices that connect, form one network in the like some draw, so they can communicate with each other directly, and I think in such situation, how you how to advertise the content information or service information? Have you considered such a requirement?
Sorry, I did not catch.
There are some complex scenario for the D2D communication. For example, the drone. There are many drones want to communicate each other. So, so in such situation, how you deliver the information at each device have, how to distribute the service container information. Have you considered?
You mean in
I want to find which device have which content. So how you find
So-
such information?
Yeah, in our case, we use NDN, right? And we use to interest. We send interest in every like a broadcast the interest. And yeah,
So every device has know all of the content our
Yes.
device.
yes.
Oh, okay, thank you.
I think it's my turn, right?
Yeah.
Okay. So, but first I want to help answer the question asked earlier. That is how this data retrieval operation matches the client server model that people are familiar with. Think about this request and the reply. It's a data-centric model, like a peer-to-peer. And therefore, each entity would behave both as a client and a server. When you request data, you can think of your client-ish. And when you produce data, you are kind of server-ish. Right? So it's really fully peer-to-peer model, as opposed to the conventional model where a party is just a client or just the server. But back to my question, not my question, my suggestion. I think in your future work, I would suggest you add one more item, which is really important, security. I didn't hear the discussion or mentioning about the word security throughout your discussion. I think in the ad hoc situations, security becomes even more important than even in the wired environment, where the adversaries can just inject the bad information into the system. Thank you.
Thank you very much.
Thanks very much. I just wanted to briefly follow up on Dan's question or comment. So why he was asking, like, why would you do this with a named data-based approach as opposed to maybe delay tolerant networking DTN approaches, which have been used for similar use cases in the past. And maybe you can correct me, but I think one of the reasons is that with like an ICN or NDN framework, you have a chance to kind of connect these both of these worlds. So the intermittently connected world with the, say, more stable connected internet. So you don't need to differentiate between those things. You have like one abstraction, one implementation that that could do both. Is that also your motivation, or?
I think because we want to like look for the content within the network, and because we don't know where actually the content is, right? So
Right.
we want to use NDN so we can address the content by name.
Right.
In like from my understanding, the DTN still like anchor the content into the location address of the node, right?
Doesn't have to be location, but yeah.
Yeah, that kind. I think that kind of can be limit the data content.
Okay. Okay. Thanks. Yeah. Thanks again for bringing your work to us. And thanks again.
Thank you very much.
So Mark is next.
Yeah.
Hey, hello.
Hello, Mark.
All right. The technology works again. All right.
Yes, you have control of the slides.
All right. Great. So we have several updates today. I'm going to start with the file-like collections. There we go. So I'll go over the updates since the 06 draft, discuss the implementation status, and then I included a few slides about some experimental results with deduplication using manifests. So there were a lot of reorganization of material, which I hope made the draft a lot more readable and concise. And the main technical updates were to the RSA key wrapping section, which is now implemented. So there was a bit of feedback from the implementation into what was in the draft. We expanded the IANA considerations, and that should hopefully be complete for all the symbolic references that we use. And we made a lot of updates to the security considerations section. There we go. So just a quick glance at the table of contents. You can see things, changed around quite a bit. The vast majority of this is just reorganizing to get like topics with like topics, so things aren't so scattered around like they were previously. One clarification that was made is that we had called Flick a manifest tree quite a bit in the draft, and I wanted to make clear that Flick is not a tree, but it's an acyclic graph, and this is very important when you want to try to do something like data deduplication. You can have nodes with multiple parents. One thing that comes up with the way that we've done name constructors is a name constructor tells the consumer how to create an interest for a hash value. And when you have multiple parents for a branch of the tree, they could have different name constructors for that branch. Like one is going to, one cache site, and another's has a different set of routing hints for it, for example, and that's perfectly fine. A consumer just needs to track which recursion they are on in a branch and use the appropriate definitions for that recursion. But this is mostly moot, because if it's a multiple recursions into the same branch, you've probably actually already retrieved those hashes and just have it and wouldn't generate any more interests. There's some ABNF updates. These are mostly in the security section, and I'll talk about those individually here. So since I believe 06, we've allowed a key derivation function in the encryption, and so this was added in more formally in the 07, and so it allows a consumer to use the same a producer to use the same secret key without being so careful about tracking re-encrypted data with the same key, or multiple data with the same key. The RSA key wrapping section got a big lift because it's now implemented, and I figured out all the things that weren't quite right with the specification for making it work. The RSA key wrapping is basically a layer around the symmetric key encryption, and it provides a way of wrapping a symmetric key into a manifest object. Is there anything I wanted to say here? So, I went through the NIST recommendations for what they call KTS OAEP, and what's in this draft should meet all those requirements if you're not sharing the RSA keys. They don't, do group keying that way, but in ICN, people have done group keying, by sharing keys. I made explicit that it's okay to use the CCNX pad field. So in particular, if you have encrypted content, you can pad it out to, some rounded number of bytes to obfuscate patterns in object sizing, which could leak information. The security considerations section, has quite a bit more in it. In specific, I talk about key lifespan and scope. The RSA OAP keys are specifically scoped to the manifest that they're wrapped with, but you can have general symmetric keys that are agreed outside of Flick. And those, need to be bounded by, the publisher that you agreed to use them with. So in particular, I mentioned, you might want to consider storing keys like that and binding them specifically to their publisher or some name prefix that they're associated with. The CCNPy implementation now implements the whole specification, and it's on PyPy now. And I've tested all the different encryption modes. We still haven't gotten it working with C4, but that should hopefully be a lot easier now that I support all of the different name constructors, because C4 didn't work with pure nameless objects. This section has just a real quick overview of some experimental results using Flick, and in particular for data deduplication. So I downloaded, some sections of the GNU source code distributions and then encoded them with Flick using data deduplication as part of the manifest building. The consumer doesn't need to know anything about the data deduplication. They'll reconstruct the data correctly just by retrieving it in the manifest order, but the producer can exploit the data deduplication. And this was all done using the CCNX nameless objects, though, it applies to named objects, you'd just have more overhead. So the idea here is every time you find a chunk in the data deduplication, you make a little mini Flick out of it that has a manifest node and then the data objects that make that chunk. And for example, doing this for the GNU patch 2.7 tar files, we have, I don't know if I have a pointer here, but we had savings of up to about 47%. Without using data deduplication, there was about a 5.5 to 6% overhead encapsulating it in a Flick manifest versus the raw size of the files. And this is all without any compression. Emacs 29, this got up to a 66% savings. And, if you look at that number, it's like 300 meg versus, 1.2 gig, for the cumulative size of these files, if as a producer you were trying to store them all. And then the Bison 3.7 and 3.8, here I showed going over a minor revision. And you still have quite a bit of savings, but it does take a little hit when there's a big version change there. And again, this was savings in around the 60%, 50% range in bytes stored at the producer or cache storing all the files, or a user downloading an update if they had the previous content objects already. So this says what I just said. Okay, so the 07 draft should be pretty close for final review. I am going to, get it working with C4, but I don't expect significant changes there as it's all kind of been worked out with the CCMPI implementation so far. And I think that does it for Flick.
Any questions? Just injecting from the chairs, we've been working on Flick for a very long time. And that work has made significant improvements as we've gotten a lot of implementation and experimental use as the whole protocol suite has evolved. So we're ready for last call, and I'll be making a last call request on the mailing list probably after the meeting, after this week, because we'd really like to push this through. It's quite technically mature at this point.
Okay, so yeah, no questions in the room. Yeah, thanks very much, Mark. It's great progress and really nice experiments. Let's move on. Now I need to take away the control first. Okay, chunking.
All right. So there's been a previous presentation on this, I think at 121. So this is just some updates since we made it a work group document. And so in summary, the way chunking is set up in this draft is you can have some preamble chunks that don't contain payload. And this is particularly important if you want to try to use a fixed sized payload to enable someone to seek to content. If you're not using fixed size content, then you can just put payload everywhere. It doesn't really matter, what the sizes are as you go through it. So there is an optional end chunk number that says where the last chunk is, and there's now an optional chunk size. So if you want to use fixed size, you can explicitly tell the consumer, I'm going to commit to this chunk size so you can seek to content. So once you find the first chunk, for example, chunk 2, that has a payload, I guarantee that all the remaining chunks are fixed size until the last one that could be smaller. You can close the chunk stream, whenever you want. For example, here, the end chunk number is 6, so it closes at 6. Since I had previously said that it was 7 in this hint that I put in 4, we recommend that you actually publish a 7 that says 6 was the last thing, so a consumer doesn't time out asking for a 7 and never get an answer. So this is taken almost directly from the draft, and it's probably beating a obvious horse over the head. So there's a chunk number in the name. You can have an end chunk number and when the end chunk number equals the chunk number, that's the last chunk. And there's an optional chunk size if you want to commit to fixed size payloads. So yeah, so this draft is probably technically done, unless someone has some input or asks clarifying questions. It needs security considerations, and probably the IANA. I think the IANA section's close to done, if not done. If you don't like this idea of committing to a fixed chunk size, you can consider doing a byte offset and a binary search. That's just a random thought put in there. I'm not planning on putting that in unless someone is going to say, hey, that's a good idea and I want that. So that's the chunking.
Any questions? Pretty straightforward stuff. Okay, let's move on to something a little newer.
Okay, so the versioning protocol. Let's see what we got here. All right, so a brief history of, I clearly copied a chunking slide deck when I put this together. So the brief history of versioning, not chunking, some examples of what we're proposing, and the proposal itself. So, back in the day, CCNX 0.x had this command marker for a version number. The version was a timestamp in the CCNX world. NDN uses a type for a version. It can be any data type as long as it matches the canonical ordering. They give examples of, integers and timestamps. In 2015, we wrote an original version of this versioning that was called serial versioning, and this replaces that earlier draft. So again, it's a very simple thing as far as the CCN part goes. There's a T version name segment that we define. You don't need to use it. There's no changes to the interest content object matching. It's still the same exact match. What we do introduce is a way for a consumer to query the current version. So we, kind of codify one way of doing this. Actually, two ways of doing it, but we'll get to that in a second. So an example of, unversion name has no version number. That's simple. A version name has version numbers, and typically it's the second to last name component before, for example, a chunk number or something like, a flick manifest name. This word manifest, there's no significance to that. I just put it in there to make the examples clearer. A name can have multiple version numbers in it. So for example, if I have some photo that's version 2 and I want to put bibliographic information related to that photo into the network, I can extend that name. So this just names one object, which is the bibliography manifest, but it's built on the prefix from the other object. So you have two version numbers, but really only the last version number is operative for that bibliographic information. So version discovery. So if a consumer wants to discover the most current version, we define this way of doing what we call a version request, where the interest has a zero length version name component. So this will essentially ask for an invalid piece of content because a version is supposed to have an actual payload there. And this gives the publisher a chance to reply with a content object that says, use this version number or use this name. The response is a normal content object. So things like the cache time and expiry time apply as normal. So it's up to the publisher to decide, do they want it to be cacheable? If it's cacheable, how long do they want it to be cacheable for? This is essentially the same mechanism that, like, Dave and I and Nacho and others discussed, eons ago about how to do, discovery in the CCNX 1.0. But we've kind of formalized this idea about what's the name you should ask for to find a versioned piece of content. So the version request, some prefix, the version number, which is empty, and then an optional suffix. You might include a key ID restriction to scope it to a specific publisher. The version response can take two forms. One is a very concise response that, in the payload of a content object simply says, this is the version number to stick into that empty template that you gave me. The publisher can include a key ID restriction or a content object hash restriction. So the resulting interest from the consumer can be highly scoped to the full name of the content object and a publisher restriction, those are optional. It should be signed by someone that the consumer trusts for that namespace or that response. Another way of responding is with a link. The CCN link has been around, ever since the it's been around almost the entire time of CCNX, going back, to the very early versions. In this case, the publisher can respond with a complete name that again has a key ID and a content object hash restriction if it wants. This allows the publisher to rewrite the request name, so it could, add more suffix components if it wanted to. There'll be some examples coming up in a minute. By a minute, I mean the next slide. So the link rationale would be, for example, the consumer just knows the prefix, but it doesn't know how the publisher stored it. Is it chunked content? Is it a manifest? Is it something else? So they just ask for the prefix for the photo, and the publisher can then say, yeah, it's version 2, and I did it as a manifest, or I did it as chunk content. So, this is, similar idea to, discovery that's been in CCX and NDN for, since the beginning, but just operated at, one level above the network protocol. All right, that is the versioning graph.
Questions? I don't see anybody in the queue. Let me just comment that while this has been based on concepts and work that's been around for a very long time, this is the first time we're actually seeing it formalized with all the details worked out. So this draft really needs a careful review by folks, and obviously implementation, people using the implementation to make sure that in fact does what we think it does. So we'll make a call on the extra call on the working list, the research group mailing list, to try and push people to do a careful review of this, since it's the first time we'll be seeing this exact draft. Any?
Yeah, let me follow up on that for just a second. The draft that is uploaded to the data tracker is a little bit out of date with this presentation. Hitoshi and I went through quite a few rounds of discussing this version discovery, and the draft that's on the data tracker hasn't caught up to the slides, but I will update that as soon as I can.
Great. As long as it happens by the end of the week, that would be helpful.
Yeah.
Okay. What's next? Reflexive?
Okay, thanks very much, Mark.
All right, sure.
Hi. So I'm Hitoshi. Much of this work has been done by him, not me. So I just thought we just thought it'd be a good idea if I gave the talk, so Hitoshi could tell me what I did wrong when we go to the microphone. So we've been working on this kind of stuff for a while. The big question is, why do we need to make a significant architectural enhancement to the conventional way that ICN protocols approach things? The base protocol architectures for both CCNX and NDN are based on two-way handshakes. It's very simple, it's straightforward. It's an interest data exchange. You send a request in the form of an interest. You get data back in form of response. And this puts you in the mindset of simply doing content retrieval, although you can, of course, do many other things with it. So why do we need this? And we've talked about this before, but it's worth refreshing your memory. So there are a number of arguments for why many applications just can't get by with a two-way handshake and need multi-way handshakes, because there are multiple use cases that work much better with multi-way handshakes. And we've seen a number of these in the past. So one that Dirk and I and some others are very familiar with is RPC, or remote method invocation, where you not only have to invoke a method, but you have to deal with argument fetching and result preparation and potentially decoupling the start of a computation with the return of the result. And when you do these sorts of things, trying to construct that out of simple two-way handshakes in one direction turns out to be somewhat difficult. Another example that we've seen in IoT systems and sensors is that if you have to keep polling sensors to try and get the results, this has a number of bad implications for bandwidth usage and timing. If you have sensors pushing data, this can have congestion and other types of connectivity problem concerns. And lastly, there's a whole class of applications that need peer state synchronization, where you have two parties. There's not directly necessarily client server, but they need to synchronize some shared state in a reasonable way. And the poster child that has turned out to be something that if you get it wrong, really bad things happen, is key exchange for security, which is a peer state synchronization. You start off with only trying to agree on either a symmetric or some kind of agreed key between two people, and you need to synchronize their state. And we also see this in things like POST and other RESTful web interaction sorts of things. So you can do these things with two-way handshakes, but has a variety of downsides that can be particularly strong if you try to use ICN protocols for it. One is that if you push data in order to get something from a consumer to a producer, this inflates the size of interests. And much of the architecture is based on the assumption that interests are small. And interests want to be small because of the way congestion control works in ICN protocols, and also the amount of router state that is kept, because if you have big interests, there's large amount of memory that's kept in the intermediate routers while the state is evolving through the exchange. And secondarily, consumers are kind of supposed to be anonymous in an ICN system. You can't you get large anonymity sets by the fact that consumers send requests without identifying themselves, and responses can come back with data. So if you need to have the producer talk to the consumer with two-way exchanges, now there's a whole bunch of fallouts where consumers need to have routable names. Depending on how you use those routable names, you can open up pretty severe reflection attacks if the consumer is allowed to convince the producer to send a request to some arbitrary routable name. So all of this sort of got us started saying, how do we produce a protocol extension to CCNX or NDN, or actually both? The spec allows you to do it in either protocol family. So we came up with this notion called reflexive forwarding. And conceptually, it's very straightforward. As interests flow from a consumer to a producer, they are creating breadcrumbs at every intermediate forwarder. You can actually use those breadcrumbs in order to send packets back over the reverse path to the consumer without the consumer having a routable address. So if you look at this typical exchange, you send an interest, which we're in our spec we're calling a trigger interest, because its purpose in many cases is to provoke the producer to send some interest in the other direction. It goes through a forward to the producer. It has some extra state in it, which we'll talk about in a minute. And that allows the producer to forward reflexive interest over the breadcrumbs in the opposite direction back to the consumer, who can then return data in a conventional CCNX or NDN data object. Doesn't look any different from one in anything else. You can have multiple of those exchanges, although the slide here only shows one for interest of brevity. And then you close the multi-way conversation by returning a final trigger data, which again is a normal data object. So that's all the background. you have to read the spec to get all the details. I'm not going to describe the spec because we've done it in the past. So but this is basically a status update. Everything I talked to about up till now has been sort of just to refresh your memory. So the first adopted version, the draft, was published a number of months ago. The authors have been working assiduously on taking feedback and experience from implementation so far to produce the next version. We've spun Ken Calvert into the team because he's done a lot of work thinking about the architecture of this and provided tons of feedback to the first set of authors. So he's now a co-author and has agreed to help us push this forward to completion. There are a lot of very small changes, some terminology changes, some wording changes, some reorganization of paragraphs. I'm not going to talk about those. You really should read the spec from top to bottom again, rather than assuming that you've seen everything before. We're learning about how this can help ICN applications today through implementations of the C4 forwarder in the NIC team, but we really would like to see other implementations of both clients and servers using the C4 forwarder, and hopefully also some other forwarder implementations, potentially, for example, if people are interested in modifying and enhancing the NIST high-speed forwarder, which is a leading edge NDN forwarder to do these functions. Now, we still have some technical issues, and I'll go through them now. So we closed a few technical issues. There was some flexibility in the spec that when we scratched our head, said, would anybody ever really actually use this? We came up with the answer no. So we had a number of options for how one could encode in the trigger interest what type of data the producer should try to fetch from the consumer. And we had 4 options for that, among which were to specify multiple fully specified data objects that it could retrieve. This obviously inflates the reflexive interest coming back, which isn't a good idea. It can inflate the trigger interest going forward. And we said, unless somebody comes up with a really strong reason to do this, it's probably not worthwhile. It's been excised from the spec, and there's a note in the appendix about rejected technical alternatives, so we don't lose track of the fact that we actually thought about this and decided not to do it. And then many of our examples that we were working with in the early version of the spec, you sent a trigger interest, there was one reflexive data, reflexive interest, reflexive data exchange, and then you closed it out. Many of the use cases are actually going to do multiple exchanges. So we tried to clarify many places in the text how you might construct multiple reflexive interest data exchanges inside this envelope. So it's clear for those use cases how to do that. So we have one could consider it big. It's really not a big technical issue, but we really would like a lot of input from the group on which direction to go, which is exactly how to encode in a trigger interest what you want the producer to request in reflexive interests. And we have 2 options. One is, since the reflexive interest has a new kind of named segment type to indicate that it's a reflexive interest, this goes in the high order name segment of the reflexive interest. We could use that same data type as a name segment in the trigger interest and make it part of the trigger interest name. And that's in fact what's implemented today in C4. Alternatively, which was in the original specification before it became a RG accepted document and is still sort of there in some ways, is to place that in a separate message level TLV in the trigger interest, whose inclusion in the interest identifies it as a trigger interest. And if you look at the two encodings, sort of look pretty similar, right? You've got the same stuff that's just in a different place in the interest message from some point of view, but architecturally, there's implications to choosing one over the other. So we've identified the trade-offs, and we talk about what are the upsides and downsides of one versus the other in the text for version 1. There may be other options for how to do this that we haven't considered yet, but please see the draft. We'd really like a lot of input on this, and potentially some more implementation work from a different forwarder that might have different trade-offs in terms of how it's designed from the C4 forwarder in order to decide between these two options. Since this is a experimental research thing, it may wind up that we do both for a while until we have a lot more experience. It may not be urgent to choose between them, but if there's a strong amount of feedback sort of moving us in one direction or the other, will eliminate one of the two options. So next step, I think I've said this 5 times now, I'll say it a 6th time, the draft really needs a wider review in the ICNRG community. So please read it, please provide feedback. We'd very much like to see it looked at much more carefully. The number of people actually looking at it so far has been very small. We'd like to see more implementations, particularly of the use cases that we identify in the draft for applications, and that could make good use for the extension. So I'm done. Questions, comments, anything else? Yes, no, maybe so. Thank you. Hitoshi? Oh, wow, thumb up. I guess I didn't do so badly. Thank you.
I was expecting a heated debate on the trigger information encoding. But okay.
I think the total number of people that have been involved in this discussion is 4, right? So far, we need more input.
Okay, thank you. Let's move on.
Okay.
Okay,
So-
I do need the clicker.
So here just we want to report our progress of the DMS. DMS is just one side meeting that we are organizing in this coming Thursday. This Thursday. So the meaning of the DMS is the distributed microservice communication. Here is the background. So what's the reason that we want to establish a new working group? So firstly, we want to solve the service mesh challenge. The service mesh is the widely used infrastructure, dedicated infrastructure, and widely used in the cloud service provider. For example, Alibaba and Google and Meta all use such service mesh to facilitate the communication of the microservice. Currently, the service mesh can accomplish the mainly 4 functions. For example, the microservice connection and the security of the between connections and the control of the traffic policy and observability. But there are some challenges to the current service mesh infrastructure. The first is it adds the complexity for the overall application, because the service mesh depend on the sidecar proxy to facilitate the four main category functions. These sidecar proxy are often co-located with the microservice itself. So because they are co-located, so their development and upgrade will influence each other. So if we want to upgrade the infrastructure, it will must consider the influence to the application itself. The second is the performance overhead, because it is same as the first reason, because the sidecar is collected with the service microservice itself. So the organization that use the service mesh must consider the impact of their applications. And the third challenge is the current service mesh is fully centrally controlled. So if there are many sidecar proxies, there will be many intense configuration overhead from the controller to the sidecar proxies. And the last challenge is function overlay, because the main function of a service mesh is to the traffic engineering based on the layer 3 information, but such traffic engineering is overlapped with the underlying network, because we know the underlying network also do the traffic engineering based on IP networks. So we think there are some function overlaps. So this is the background that we want to build one distributed microservice communication to solve such challenge. So the BOF and RW working group the aim is to build one service-oriented distributed infrastructure. I think the service-oriented may be aligned with the aim of the ICNRG working group. So we will try to use the existing technology that developed by the ICNRG, maybe tailored to our required scenarios, and we will focus on the there will be control plane extension and the forward plane extension. For the control plane extension, we will try to reuse the existing control protocols. For the forwarding planes, we want to tailor in the existing various HTTP method and TCP-based microservice to the contained semantic-based networks. And the final goal is we want to build one contained-based scenario network. From the two finger 1 and finger 2, we can see the difference between them. Currently, the service mesh is one overlay layer to accomplish the traffic engineering based on the information, based on the layer 7 informations, and we want to contract such functions into the underlying network device. So keep the network more simple and more controllable. Here is the scope of the DMSC. We first want to solve the challenge from the service mesh, but currently there are other scenarios that require the distributed service. For example, the distributed AI or in-network communication. We will consider these scenarios together, and there are problems and common requirement. And the second, we will, based on this problem and scenario analysis, we will want to design one distributed service network, and also design the design of the new network device. So we will also consider the challenge analysis for the future development in the large scale, because we are from the operator, so we must consider the in the future deployment in large scales. And the last is we want to build one new standard, and we are cooperate with the network device vendor to want to implement a new device and also build a network based on this device. We have held one simple of DMS in Beijing in March 6th, and invite about 14 presenters, 14 topics, and to discuss around these topics. There are about 30 persons attend, and we have selected 6 of them make the practice at the coming side meetings. So I think if you're interested, you can come to the side meeting and to listen to the detailed analysis. So here is the final aim of the this working group. The first is we want to focus on to solve a challenge from the microservice communication. The second is we want to consider also the emerge from the requirement emerged from the distributed AI in network computing and our news broadcast. We think they are all the distributed service we can try to accommodate this service in one networks. Here is the draft agenda of these side meetings in this Thursday and the afternoons meeting room. So we are welcome you to come here to give your comment or suggestion for the forwarding of the working group. So this is the draft plan for the DMS both. Maybe I think we think we maybe hold several side meetings, and then if they have agree with the aim and the deliverable content, we can try to organize the formal board meetings, and after the approval of the idea, we can try to establish the DMS working group. Okay, so we are welcome you to join us together. Here is the mail list. We have if you have any question, you can ask within the mail list. We will respond to you. Okay, thank you.
Thanks very much, Arjun. I have a couple of questions. So first of all, so you mentioned container, right? So is this a crucial element in your design that the units of execution are actually containers, or could this be also other units like processes or something else?
We for implements of deployment, we don't limit it to the containers. You know, we want to put such function in the traditional network device. So because you know you will hear the introduction from Alibaba in the side meeting. They have do such work. They have put the sidecar proxy out of the container and into an independent device to accomplish the similar functions.
Right. So
because they also realize the such challenge for the co-locator device.
So yeah, I just wanted to understand. So what are the kind of assumptions and constraints on the design? So are you basically trying to build a replacement for current microservice systems that kind of feel like the same, like for applications, or are you kind of trying to redesign a generally better system? So that doesn't have any notion of sidecar and maybe doesn't need to have the same APIs for the applications. How open are you to like new designs?
We just want to design the new system to accomplish the same functions, and
right.
Yeah, because the service current service mesh can provide such functions. We want to we build the distributed communication infrastructure has the same functions.
Yeah.
Maybe there are some different entity to accomplish such abuse. For example, we may have the gateway to make the forwarding plan translation, and the container service router to make the service information distribution. Maybe different kind of network device can together action together to finish the same functions.
Right. So, and then since you mentioned also like AI communication, right?
In network communication, also
Right.
AI.
So I was wondering, so what have you included in your state-of-the-art research? So, for example, there are systems like distributed computing systems such as Ray, which is used for training ChatGPT. So I just want to be sure. So have you included such systems in your analysis, or is this out of scope because it's not traditional microservice architecture?
Firstly, we want to focus on to accomplish the same function for the service mesh, but we also want to include the requirement from the distributed AI and internet. You will notice the second presentation from Huawei will introduce their research in the in-network data communications, and we also invite the service provider to attend the side meeting. And you can see from the scenario of our meeting in March 6th, you can see more vendor. For example, the Centec. Centec is switch vendor. They have they are same as they have some prototype for the in-network device. So we have discussed them. Okay, but the in-network device is not our mainly aim, because currently we cooperate with Alibaba Cloud. So we want to first meet their requirement and consider together the distributed and in-network functions.
Okay, thanks. So we have more questions in the queue, Hitoshi.
Hitoshi Asada. So it's not a technical question. So, well, this is a research group. You want to propose a IETF working group. How you interact with ICNRG and your proposed working group? It's just curious.
Well, I mean, we just invited Arjun to give us an update so that people are aware of these activities, and if they're interested, they could possibly, check it out. So the idea is to use ICN principles, and that's why we thought it could be interesting for the group.
Okay, so if your proposed working group is formally formed as a working group, that working group will provide some, let's say, something like a format or some standardized. So because we have several CCNX or NDNs packet format we have been discussed and implemented, but research group doesn't care so much about such kind of format itself, right? So it's because still this is a research group, so you can just copy. Well, you can copy to the.
We have investigated the current standard of the RC produced by the ICNRGs, and currently we know it is impossible to use them directly in our scenarios. We may do some change or adaptations, because currently within RCN technology we build the communication based on the interest and the data patterns. So, but for the Microsoft communication, their communication path may be different. So we may design newly protocols, but maybe refer to some design from the ICNRGs.
Okay.
So that would be very interesting for us to learn, right? So what are the say insufficiencies of current ICN protocols for supporting microservices? That'd be really interesting to know if you could share this at some point.
Okay, thank you.
Hi, Dmitry Kuznetsov from University of Amsterdam. I hope this is within scope, but I noticed in the slides, and you mentioned content-based routing. So as part of developing this standard potentially, would you also need to develop a new way for service providers to announce content of all packets? And so you would need to also standardize that element?
My background is routing technology, so I'm very familiar with control protocols. So we think it is very easy to distribute the service information in control planes. But I think the most challenging for me is for us is for the data planes, because currently the service microservice is based on the HTTP or Quick or other protocol. We must adapt to them to the content based. So this may be the most challenging. So we think we want to seek some help from the experts from ICNRG to bypass these obstacles.
If I can follow up, do you see it as an announcement of broad content type, such as you had podcast, newspaper, AI training data, or do you see it as a full understanding of the content of the message, let's say the content of the podcast itself?
Maybe the content identifier, only.
Okay.
Yeah.
Yeah,
Because
thank you.
currently the service mesh is also based on the content identifier.
Okay, great. Thank you very much.
Thank you.
Hey, thanks. It was great presentation. Hello, Chair. So this is my first time. I'm Tushar from Tata Communications India, and I'm working on something similar, but my approach is a bit different on the CNI side. I'm building a different kind of CNI, which can carry this information, but not looking into the service mesh side. Service mesh, during my initial study, had some problems because today's service mesh using ISTI or the sidecar principles that we discussed, primarily consist of a lot of complexities around app service-based load balancing, or a kind of intelligent filtering that we do on a edge cloud, right? Edge is mostly distributed. And when we have multiple nodes in the cluster located geographically at different places, or multiple clusters itself hosting the same service, the service mesh, do not consider, if we implement this content-centric service mesh, it doesn't consider those filtering and complexities. So is there the similar problem that you also faced, and are we working towards making something from the working group around this? Is my question clear? So let me give a very small
So would you like to ask the question on our list? I think at here, I can answer you more clearly.
Absolutely. I'll do that. But just to give an example, what I'm trying to say is the floating IP that we assign to a service, right, internally gets load balanced across the different applications. So you spoke about a container, right? Now, same container, could be, there could be multiple containers generating the same data or the same prefixes, right? Now, how do you pinpoint from the content mesh? And we have seen, the interest, being the primary interest, and then from there, it replicates. So how these two things are combined together, that is what I'm not able to understand, though I know that it can be load balanced in a proper way, and service mesh could be made very beautiful with this. But how and what is something which I can't imagine. And I was expecting if something from a working group can come out, that this could be a new idea. So that's what I'm expecting.
So your question is, you just doubt the aimed DMSC can accomplish the same function as the current service mesh?
Exactly.
No, I have concern because I have reviewed their main function. All their currently doing things is very similar that we have doing many years in the traditional networks. I think we can find the right solutions. I have the confidence.
Understood. But I'll anyways put on the mail. Thank you.
Okay.
Okay, thanks, Arjun. So for people who are interested, maybe check out this side meeting. And thanks, Arjun. And to wrap this up, so just want to make you aware of the NDN community meeting that is on April 17th and 18th in UCLA in California. And I think you can participate online if you're interested. And then, yeah, we would have the next IETF meeting in Madrid. So, I mean, we have a couple of things in the pipeline that will certainly progress. If you have anything else you would like to discuss or share, it's good to reach out to us as soon as possible so that we can plan this well. Anything else?
Nope.
Okay, and with that, thanks very much
Thanks, everybody.
for coming. See you again soon.
Especially those of you remote in the middle of the night and other inconvenient time zones.
Yeah. Okay. Thank you, Dirk. Well done.